Hello, everyone.
Hello, sir.
I believe we should be ready now. So far, we have been using what is called the waveform generator to give an input and get the output of the circuit that we are building. And today we are going to learn something else that's called test bench, the simulator, Quartz simulator. This is the structure of my VHDL program. And the test bench is right in here. It is just for software simulation. It does not get into the board itself. We cannot download it to the circuit board. So the test bench is outside. It gives input and output similar to what we have seen before with the waveform generator. Here, this is a little bit more portable. You can generate files and you can keep them. You can handle more sophisticated waveforms as input and output. Would you please start opening this file?
Where is it?
On Canvas, where it will be. This is how it would look like.
Professor, is it the Introduction to Quartz 2 Software with Test Benches, Part 2 PDF?
This one. This is the first page.
Are you going to share your screen?
Oh, sorry.
That's why I was confused.
Yes. Can you see it now?
I can see it now.
Okay. No, do you have it on your computer? Download it from Canvas.
Not yet.
Okay. Vitaly.
Yes, Professor.
I had some trouble with my computer, so I couldn't run this program. But I ran it before and it was running, but right now I have some trouble with my laptop, so I cannot run it. So I will stop sharing the screen and you will be sharing your screen and we are going to follow the instruction here on your computer.
Is this in Quartz or just the PDF?
No, I'm not saying sharing this file. We are going to do the instruction on this file together.
Okay. So you want me to share my screen in Quartz?
Yes. But
okay.
I need you to get anyone, the simplest program that we had. Any of the simple program, even the AND gate, the one I sent you, if you have it.
Okay. Let me see. Let me just pull up that program in Quartus first.
Okay.
1 second.
So that thing you wanted to open, us to open is Lab 1B VHDL Logic Core to 6.
Anyone, any lab.
Okay,
We are gonna follow the methods that we have, and hopefully it would run. Is there a problem with it, Vitaly? Do you have a problem with it?
No, not yet. I'm just opening up a file. Just making sure that it opens. Okay, I'm going to share my screen and I have the basic gates
Okay.
file open. So 1 second.
Do you have any simpler one? This has many inputs.
Yes, let me get a different one.
Just one AND, that would be easier.
I mean, I have the file saved. I can just like delete the other gates. And do you want the schematic or the VHDL file?
Whatever you like.
Okay.
Just get me a simple file.
I didn't see where you got that file. It's in Discord, right? Or not Discord, Canvas.
Hello, Samuel.
Hello. It's in
You have the
Canvas.
file we did this morning. Did it work well?
Yes, it did. Outstanding. It worked like a charm.
Would you please share the screen with this and start it from the beginning? Start it
Okay.
from the beginning.
It'll take me 20 seconds to log in from my laptop. So 1 second.
Okay.
I do apologize, guys.
I have a cold right now.
All right. And you wanted me to bring up the Cordis light.
Yes.
And would you like,
Open project. Open
Yeah.
project.
okay, the project that you had from Canvas, I did not see where you guys got it from.
No, no. Open the project that we did this morning.
Yes, sir. Got it. 1 second.
No, we have to go back. Go back. It is not going to open this way.
Okay.
Close Cordis and start it all over again.
All right.
Cordis. No, open Cordis. Don't open it from here. Open Cordis. Now open project. This open project, not project wizard. Cancel. Open project. Now we tell it where is it.
Do I need the board hooked up?
In this project, we did it this morning and we compiled it. It is running. Control L to do it one more time. Now
My
we have,
process.
yes, we have VHDL program that is running. And we're gonna, after we make sure that it is error-free, we are gonna take several steps, very lengthy procedure to get this test bench. Full compilation was successful. I want you to go now to assignment. Very top, assignment. Yes. And from assignments, we need to go to, just a moment, please. We need to go to settings. Now we have, just a moment. We have in their category settings as EDA tool setting. EDA tool settings, yes. And we take simulation. Simulation on the left, on the left, on the left, on the left. Yes. Here, we need first to change the Verilog HDL. Yes. And we know we want to go to more EDA netlist writer. Yes, here, click here. And we are gonna select from this one, turn on generate netlist or function simulator. Can you find it? Generate function simulation netlist. Yes. Okay, that's another okay. Accept this. We are Yes, we are on page 3 right now. Are you all following? We are on page 3, but page 3, it is if you have a schematic, a block diagram schematic, and you want to convert it to VHDL. But here, we don't have this because we have our own VHDL already. So we don't have to worry about this.
Can we look at the program again?
Yes, we are going to go now to part 2. We finished with this one. This is page 8. On page 8, we go to processing, up top, yes, start, not start combination, start, and here you are going to find start test bench template writer toward the end, down, yes. This one will generate a template for us. This template, it is for the test bench. It will give the test bench the input waveforms that we want to get. Now, this has been generated and it is located on your hard drive. Now we need to open this file that was generated. Go to File, Open. Go to Simulation, Model Sim. Go down to which files. I need all files. This, yes, very bottom. You have Butcher VHT, the second one. Yes, this one. Open. Now we have this file that was generated. And if you go down, begin, then there is a comment statement. At the end of the comment statement, new line. Now we need to enter our code. To enter our code, let's get back to your VHD program, the main program. The main program, yes. Yes, from here. Copy pin name 1, copy it as it is. Not all of it, just pin name 1. That's it. Copy. Now go to our VHD, paste. Here I put less than sign equal 0, semicolon. Paste one more time. Paste one more time. Paste the same pin. No, over there, up there, up, yes. But make it pin 2, yes. Now, less than, less than, equal 0, semicolon. Enter. Wait for 100 nanosecond, NS. Wait for 100 NS, yes. Now copy those 2 lines and paste after the 100 NS. One more time. I needed four of those. 4, just one. For the first one, I started with the 2 inputs. You remember, we need first 0, 0, then 1, 0. So pin 1 will be 1. 0. Then 0, 1. Then 1, 1. Delete the last one, wait for 100. Yes. Okay, great. Control S to save. Now we need to include this file in our test bench. We go to one more time to processing assignment, settings, simulation, yes. Now I need to go here after the EDA and there is none, there is compile test bench, not selected, down. Compile test bench, not selected. Yes, I selected. Now I go to test bench, new. Call it the same name. Yes, no. Then we go down to here, file name. File name, there are 3 dots. No. 3 dots. Yes, I go simulation, model sim, the VHT, the second one from top. Yes, open, add, okay, another okay, okay. Now we added this to our project. Now I go to my project up there, add current file, the first one. Yes, we added it. Now processing start, then yes, elaboration, the second one from top. Yes. Now we go to processing. Start. Just on, please. No, sorry, we go to tools. Tools. Are we in tools? The first one, run simulation tool. Just a moment. We are looking for run EDA simulation tools. Can we find it? Not here. So we take the first one. It should have another file generated or another window. Yes, here it is. The first one to the left, work, expand work. This work down here, yes, on the selection on the left. on the left, the first one, expanded, plus, hit the plus. Okay, we need to, don't expand the second one. Now we need to take those two files, highlight them. Yes. Left mouse, recombine. Failed. Okay. The same error I got. I believe I followed the instruction to the letter, but anyway, it didn't work. Okay, guys, stop sharing the screen, please. We'll continue with our waveform generator as we did. This is a program. For this program, it is gate 1. And as you can see, it takes A, B, and the output is C. And what it does is just a simple AND.
Professor, are you sharing your screen or no?
Oh, I didn't. This is the first one, gate 1. And what about this one? This one, it is the main program that will call the component gate 1. Last time we saw how we can call the full adder 8 times to make 8-bit full adder. Here we are going to see another example of using the component. Here, as you can see, this is my main program. Can you see the entity? I have nothing in here because it is relying on the component that is coming from outside. So this one will have entity, nothing, and I have the architecture that is using this entity. The folder name will be this name, gate1 underscore VHD underscore TST. And since I don't have input output, I have just signals, A, B, C. Those are my 3 signals. Now I am within the architecture. Component, as we know, I am going to copy the component entity and put it in here. This one, I copied it, but I'm calling it component. And this is the instantiation of my component, I1. I am calling what? Gate 1. And I am assigning A to A, B to B, C to C. Here, for this one, I am giving my input output from this main program. It is passing to the component the main input output. A will be 0, B 0, wait for 10 nanosecond, change A to 0, 1, then 1, 1. Those are my inputs. When I call gate 1, I will go and call my process and feed it with this number in sequence. 0, 0, wait 10 nanosecond, 0, 1, 1, 1. This is how it would work. Now we go to another program. For this program, it is D flip-flop. D flip-flop. We know for a D flip-flop, it needs clock, D input, and Q output. And Q will follow the D if there is a rising edge. So my synthesis will be process, clock, begin. If rising edge, clock, then U equal D. Q will be assigned, D will be Q. We had those before. I believe that was part of your homework that we did. Here it is a repetition using the test bench, which didn't work well with me today. All of those are just the same program we did before, but with test bench. And this is the counter. I will speak about counters in details, more details. In our assignment this week, we have two assignments. One is to build shift register, and the other one is to build a counter. I will speak about shift register. It is a reminder, or it is going to be new for those who didn't get the EE133. Shift register, it is one way to store data using shift register, and it can be made of D flip-flop, where output will follow the input upon receiving a clock rising edge. And our shift register normally takes data in as a stream. This is serial in, and as the data progresses into my D flip-flop 1, 2, 3, 4, finally it will come out. So serial in and serial out, data comes in as a series of data, and it will come out as a series of data. As you can see here, the data going in left and leaving from the right, or it can go in the opposite direction come from right and leave left. So I have left shift or right shift. I have another version of the shift register where it is parallel in, serial out. I load 4 bits and I'm getting out one by one. With each clock, I get one out. I can get serial in, parallel out. As I push the data in, they will come out from 1, 2, 3, 4. After 4 clocks, the 4 bits will be out. I have another shift register that is parallel in, parallel out. I have another one, rotate. I can rotate, that means I enter my data and it will rotate and enter one more time and keep on rotating, right? Or it could be rotating left. Those are the 4, 6, 7 types of shift register. Now let's go into more details. I have here 4, 5 D flip-flops. With the first clock, I have the serial data input 1. Now the 1 is at the output and it is entering D1. One more clock. The same one traveled and crossed flip-flop 1. One more, flip-flop 2, flip-flop 3. Finally, it reached the output after 5 clocks. For this one, suppose that we wanna push this 4-bit 0, 1, 1, 0, 1, 0. This is my starting point here. After each clock, my data is traveling to the left. So clock 1, my first 0 is here. Clock 2, I have the 1. Clock 3, 0, 1. The same thing. It is happening because I have my stream of data is traveling from left to right. What will happen after I finish with this data? I'm not entering anything. That is why at the end, everything will be 0. Yes, here, 0, 1, 0, 1. Yes, I managed to get that, but this is after 4 clock cycles. What about clock cycle number 5? I'm not feeding anything, so this will be 0. Clock number 6. Oh, I'll have 2 zeros. I'm inputting nothing. Clock 7, 3 zeros. Clock 8, now it is all false zeros because I entered only 0, 1, 0, 1. And those are ready to be available after 4 cycles. Whenever you push more clocks and you have nothing at the input, it will be replaced by 0. And this is as a table. I started here initially. Then first clock 0, 1, 0, 1. This is the timing diagram. I am inputting this data in. This is my stream of data. 1, 1, 0, 1, 0. With the first rising clock, Q0 will be high. With the second one, it will be high also. But with the third one, here I have a 0, so it will go 0. Fourth is high, fifth low. This Q0 is copied to Q1. This is the data in, this is Q0. Q0 is copied to Q1, but shifted 1 clock cycle. You can see the same thing, but shifted 1 clock cycle. Q2 is a copy of Q1, but shifted 1 clock cycle. Q3, copy of Q2, shifted 1 clock cycle. Q4, the same thing. Now we're going to see serial in, parallel out. Serial in, parallel out. This is my D5 flip-flop. Serial, after 1 clock, it will be here. Then here, here, here. After 4 clocks, I have the 4 bits ready to be read. This is 1. Shifted. I'm feeding 1, 0, 1, 1. Now all 4 are ready. We can read them from the parallel out. In this circuit, I need to tell the output port that all data have been inputted and we are ready for you to read. So we may need a counter for that. Now, after 4 clocks, I can send the data out. This is how the waveform would look like. This is a TTL that can do the same thing. Here, I am getting the serial data in. It will propagate through the 8 shift registers, 8 shift registers, and by the end, I will get the output of 8 bits. Here it has extra feature that is clear. In addition to clock, I have clear. I can clear everything immediately. You can see here, I started with clear low. This bar means clear will be active when it is low. When it is low, I can see all output is forced low. Now, it is high. And now I am ready to follow my A, my serial input A. And my serial input A, as we follow it, when we have B high, it will start from here, that is A low, another clock A low, then another clock here we have A high, I am following it, another high, this clock OA is low, so I go low. Then this clock A is high, so I follow it. Please note here, I didn't change, A has changed, but I'm not going to change until the next clock here. This clock, I get low. This is the first Q0. Q1 is a copy of it, just shifted one clock cycle, and so on. Another type of shift register that is parallel in, serial out. I have my 4 inputs. When I select load, that is low, when I give here load, all my 4 inputs will be here at D0, D1, D2, D3 will be available here. Then when load goes high, that means shift. I am ready to get the output here, D3, when the clock comes. Clock is in, I am with D3. Another clock, I will get D2. Third clock, D1. Last clock, I get D0. So I loaded the 4 bits, then I'm getting out one by one. This is parallel in, serial out. This is an example of parallel in, serial out. The 4 bits were loaded, and I'm getting them one by one. And this is a commercial shift register. And that is how we may get its output. This is parallel in, parallel out. I load 4 bits simultaneously, and I'm getting them all out simultaneously. This one will do parallel in, parallel out. When we get J key to be identical, I start getting my parallel out. We'll stop here and we'll continue on Wednesday. Would you please,
Thank you, Professor.
would you please try to follow the instruction on how to do the test bench? Anyone who succeeds, he will get a bonus. Okay? It was running, and I believe I saw it running, and I ran it before several times. I don't know what is happening. So please read it, and if you succeed, just please let me know. Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you. Bye-bye.
Thank you, Professor. Bye-bye.
Thank you.